Hello there. Welcome to your next math lesson. Today's lesson is called Subtract Unlike Fractions. So go ahead, open up your math notebook, and please write that at the top of the next available page. Subtract unlike fractions. So we already know that unlike fractions are fractions that do not have the same denominator. Like fractions are fractions that do have the same denominator. So subtracting unlike fractions is, let's say you're in a situation like this where you have 5/6 minus 1/2. Notice this fraction, 5/6, has a denominator of 6. This fraction, 1/2, has a denominator of 2. Those are different numbers. So these are unlike fractions because they have different denominators. And in order to subtract this, you need to follow 3 steps. Step 1, find common denominators. So that's just another way of saying you need to make the denominators the same. You can't subtract until you make the denominators the same because the numerators don't mean the same thing. Okay? Step 2 is subtract the numerators and leave the denominator the same. Okay? Subtract the numerators and leave the denominator the same. That's the second step. And the third step is simplify. Now, before we subtract this, let's take a second and look at why it's so important for us to follow step 1 before starting on step 2. Let's say this was pizza. Let's say we had 2 pizzas. They're exactly the same size. And you and your friend are eating these 2 pizzas. Now, your friend's pizza is cut into 6 slices. Your pizza is only cut into 2 slices. Okay? So you have like really big pieces of pizza. That'd be really hard to eat. Now, your friend's really hungry. He eats 5 out of his 6 slices. 1, 2, 3, 4, 5. You're pretty hungry too, but you only eat 1 slice. Now, would it be fair for your friend to say, dude, I ate so much more pizza than you? I ate 5 slices and you only ate 1. Why would that not be fair? Now, while it's true, you can see he did eat more pizza. Why can't he say, I ate 5 slices and you only ate 1? Well, his 5 slices, his 5 doesn't mean the same. If you ate 5 of these slices, you would have eaten way more than him. So because your denominators are different, the amount of slices don't mean the same thing. Slices here don't mean the same thing as slices here, so we can't subtract the numerators. We can't say that he ate what? You ate 1 slice, he ate 5 slices. 5 is 5 times more than 1. Can we say that he ate 5 times more than you just because he ate 5 slices and you ate 1? No, because your 1 slice is so much bigger than each of his slices. And that's why we have to find common denominators before we subtract, because while we have different denominators, the numerators don't mean the same thing. Okay, so now let's follow these steps to make common denominators. Step 1 is find common denominators. Now, how do we do that? First of all, the first thing I always recommend is stack the problem. Don't try to solve it across like this. It just gets too confusing when you make common denominators. It's better to do it up and down. The first step, find common denominators. We have to list the multiples for both denominators until we find the LCM, or the least common multiple. So we put 6 here and 2 here, and we count by 6s and we count by 2s until we find a number that's in both lists. So we're going to count by 6s, 6, 12, 18. Now, I kept going, but some of you could see as I wrote that first 6, you could see, hey, 6 is a multiple of 2. And that's true. Let's count by 2s. 2, 4, 6. Look, my third multiple of 2 is my first multiple of 6. Now, I could keep going, and I could list multiples forever because multiples never stop. But there's no reason for me to go any farther because I'm looking for the least common multiple, or the smallest number that both 6 and 2 have in common as a multiple. So I'm going to circle 6. That's my least common multiple. Now, what am I going to do with that? I'm going to make new fractions off to the side that are going to be equivalent fractions to the one next to them, but they're both going to have 6 as a denominator. Now, I actually don't really have to make a new fraction here because this one already has 6 as its denominator, but I'm going to anyways, just so you can see the process, because it doesn't always work out like that. Okay, so now that I have my new denominators, I need to make my new numerators. And how do I do that? I do it by multiplying from my old denominator to my new denominator. So I think, what times 2 equals 6? 2 times 3 equals 6. And then whatever I do to the bottom, I have to do to the top because I'm making an equivalent fraction. So I multiplied 3 by my denominator 2. Now I have to multiply 3 by my numerator 1. And 1 times 3 is 3. So now I've made an equivalent fraction. 3/6 means the same thing as 1/2. It has the same value, but it has 6 as a denominator. And that will make it a like fraction with the fraction I'm going to make right here, which will also have 6 as its denominator. And actually, I didn't even have to make a new fraction here because 5/6 already has 6 as its denominator. But let's just do it anyways. What would I have to multiply from my old denominator to my new denominator? Well, 6 times 1 is 6. Whatever I do to the bottom, I have to do to the top. 5 times 1 is 5. Okay, now I've just done step 1, find common denominators. My common denominator is 6. Now I can subtract these. My next step is subtract the numerators and leave the denominators the same. So I subtract 5 minus 3 and I get 2. And 6 is my denominator in my minuend and my subtrahend. So I make it my denominator in the difference as well. And step 3 is simplify. I cannot leave this the way it is. Why? Because 2 and 6 will have a greatest common factor above 1. That means it's not already in simplest form. So how do I put it in simplest form? I list all the factors for 2. That's only 1 and 2 because 2 is a prime number. And I list all the factors of 6. 1, 2, 3, and 6. And the reason 1, 2, 3, and 6 are all the factors of 6 is because 1 times 6 is 6, 2 times 3 is 6. Nothing else can be multiplied together to equal 6, so there are no other factors of 6. Now, I find the GCF, or the greatest common factor. That's 2. It's the biggest number that's in both lists. And what do I do with that GCF? I divide my numerator and my denominator by the GCF. So 2 divided by 2 is 1. 6 divided by 2 is 3. And my final answer is 1/3. So 5/6 minus 1/2 is 1/3. That's how you follow these 3 steps to subtract unlike fractions. Let's do another example. Now, you can't see the 3 steps anymore on my screen, but hopefully you wrote them down in your own math notebook, so you still have them in front of you. Let's do 2/5 minus 1/4. These are unlike fractions because this one has 5 as its denominator and this one has 4. Now remember, the first step that I always recommend is stack the fractions. They'll often be presented to you like this, across, but don't try to solve them like that. Put them on your scratch paper like this, up and down. That way you can make equivalent fractions off to the side. It's a lot less confusing. Okay, step 1 is find common denominators. So I write down 4 and 5, and I list multiples for each one until I find the LCM, the smallest number that's That's a multiple for both 4 and 5. Another way of saying that is I just count by 4s and I count by 5s until I find a number that's in both lists. Once I find that number, I don't need to keep going because I'm looking for the smallest one. So I count by 4s, 4, 8, 12, 16, 20. I know I'm going to get to 20 if I count by 5s. So there's no reason for me to keep going. 5, 10, 15, 20. And look, there's my LCM, my least common multiple. Now, some of you are thinking, Mr. Dauber, I wouldn't have known to stop right there. That's okay. It just means you would have gone a little bit farther. That's all right. You would have done a little bit of extra work, but it doesn't really matter in the long run. You still would have found out that 20 is the LCM. What do we do with that 20? We create two equivalent fractions off to the right side of our old fractions. They're both going to have 20 as their denominator, so they'll be like fractions. But this one will be equivalent to 1/4, and this one will be equivalent to 2/5. The reason we know they'll be equivalent is because we're going to do the same thing to the bottom that we do to the top, the same thing to the top that we do to the bottom. That's going to make an equivalent fraction. So we multiply from our old denominator to our new denominator. What times 4 equals 20? Well, 4 times 5 equals 20. And if you're having a hard time with this part, use your times table chart. Okay? Now, whatever I do to the bottom, I do to the top. I multiplied 5 times my denominator. Now I need to multiply 5 times my numerator. 1 times 5 is 5. 5/20 is an equivalent fraction to 1/4 because 5 takes up the same amount of 20 as 1 takes up a 4. You can fit 4 5s in 20, and you can fit 4 1s in 4. That's how you know they're equivalent fractions. Also, you know they're equivalent fractions because you multiplied the same thing by the numerator as you did by the denominator. Now, we do the same thing up here. What times 5 equals 20? 5 times 4 equals 20. And again, if you have a hard time figuring out what number goes right there, use your times table chart. 5 times 4 equals 20. Whatever we do to the bottom, we do to the top. 1 times 4 equals 8. Now we subtract. The second step is subtract the numerators and leave the denominator the same. So 8 minus 5 is 3. I have 20 as my denominator in my minuend and 20 as my denominator in my subtrahend. So 20 is the denominator in the difference. It stays the same. You don't subtract 20 minus 20. You just leave the denominator the same. And the answer is 3/20. This one won't have any common factors above 1 between 3 and 20. 1 will be the greatest common factor. Yeah. Okay. Thanks, Jeff. 1 will be the greatest common factor for both 3 and 20, so it's already in simplest form. Now, let's pretend we didn't already know that, because maybe some of you don't. How would we find out that that's in simplest form? You find out when you try to simplify it. Because if you list all your factors for 3, it's just 1 and 3, since 3 is a prime number. And then when you list your factors for 20, 1 and 20 are factors of 20. 2 and 10 are factors of 20. Nothing times 3 equals 20. 4 and 5 are factors of 20. And then nothing times 6 equals 20. Nothing times 7 equals 20. Nothing times 8 equals 20. Nothing times 9 equals 20. We already know 10 times 2 equals 20. And once you get to half of the number, you're done. So those are all the factors of 20. And then when we look for a GCF here, the biggest number that's in both lists is 1. So 3/20 is already in simplest form. Okay, I've done 2 examples with you. I'm going to give you some independent practice problems now, and I'd like you to try to do them by yourself. Okay, let's see. I'd like you to do 7/8 minus 1/2. Go ahead and do that independently. And I'd like you to do 7/12 minus 1/3. Go ahead and solve those 2 problems by yourself, and then click on the video attached underneath this one to see if you did them correctly. And I will see you there. Signing off.